let's look at the integral of ln x, or the natural log of x. Now this integral is a special case of integration by parts, and the integration by parts formula is given by the integral of uv dash is equal to uv minus the integral of vu dash, where we have the product of two functions, where one of them we label as u and the other function we label as v dash. And so we have the integral of ln x with respect to x, and this can be written as the integral of 1 times ln x with respect to x, since 1 times ln x is just equal to ln x. And because we now have a product, we can now use the integration by parts formula. And so we start by labeling one of these u and the other v dash. So let's suppose we let u equal to 1 and we let v dash equal to ln x. Then in this scenario, we need to work out u dash and we need to work out v, where u dash is the derivative of 1, which would equal to 0, and v is the integral of ln x. But since we don't know what the integral of ln x is, labeling u as 1 and v dash as ln x would not be helpful in this case. And so we're going to label these the other way around. And so now if we work out what v is, this is the integral of 1 with respect to x, which becomes x. And now if we work out what u dash is, this is the derivative of ln x, which is 1 over x. And so using our integration by parts formula, we now have that this integral equals to uv, so that's ln x times x, which is x ln x, minus the integral of vu dash, which is x times 1 over x. And so this now simplifies to x ln x minus the integral of, and now x times 1 over x equals to 1, and we're integrating this with respect to x. And so finally, if we work this out, then we end up with x ln x minus, and now the integral of 1 with respect to x is just equal to x. And since we have indefinite integration, so that's integration without any limits, we add on the constant of integration, so plus c. And so therefore the integral of ln x with respect to x is equal to x ln x minus x plus c.